Thanks, Don, and good morning, everybody. So I'd just like to give a brief update on our project, which is essentially coming to its end very soon, and also I guess that this is a good opportunity while I'm here, so I can probably not discuss now, but during this day to find out basically where we can take the final stages of the project to bring the best value out of it. But anyway, the project, as Don mentioned, features a trial of ceramic membranes in Melbourne, and in this application it is the first in Australia. So the project participants, so we're operating the project and we're working very closely with Melbourne Water, who's hosting the trial at Eastern Treatment Plant. And on the project as well, we have South East Water, Black and Veatch, Water Research Australia, and the technology providers, so the ceramic membranes are coming via PWN Technologies in the Netherlands. So the objective set out at the beginning was to essentially bring a pilot to Australia and run it for at least a year on secondary effluent. And then with that, it's already known that the ozone increases efficiency in terms of flux because there's a catalytic effect on the membrane, which is actually a new concept in water treatment generally. So we wanted to first prove that, which we did. But of particular novelty in this project was to start to look at how this technology will inactivate pathogens or remove pathogens. So we ran some tests there, which might help guide some disinfection objectives or design for future work. But we also looked at general performance such as colour removal as effect of the combination of the ozone and the ceramic membrane. We also had an objective, it's in the title of our project, to look at chemical reduction. So we wanted to see if the ozone effect on the membrane can offset the cleaning chemicals that are typically required in a membrane plant. So we've got data there. And then at the bottom line of at the bottom of all of this, we wanted to then find out essentially what the whole thing costs in the context of water recycling and if there's actually cost advantages over conventional technologies. And then essentially because it's a research project, we want to disseminate all the outcomes and receive feedback and of course demonstrate the technology to the Australian water industry for them to consider further. The project, as I mentioned, it's coming to its end, so it's effectively had 3 phases. The first was a setup, then the site trial, so phase 2, and then phase 3. Now we're at we've finished the trial, so it's been wrapped up. We've got all our data, and now we're preparing essentially the outcomes of assessing the data, which includes the economic assessment. So in terms of the outcomes, so from an industry perspective, there's evidence of the performance of the viability for water recycling, so that's been shown. We have the data for the low chemical and high performance operation modes, which seem to be 2 of the main potential opportunities for the technology. We've all got value on integrity monitoring, and also so essentially the pathogen rejection potential for the technology, which is I guess is a first for the technology. Scientific outcomes, so being a university, we like the science. We've got more information by having a pilot. You can't do this in the lab. You've got a pilot. You can run a few simple experiments to explore that effect of the ozone on the surface of the ceramic membrane, which is quite interesting. And also just the evidence of that pathogen remove concept. So effectively, you've got a new concept. We've got a continuous ozone flow with the pathogens, so bacteria, say E. coli, we use as the indicator, stuck on the membrane with continuous ozonated water flowing over it, which is not like other membrane processes. And we were actually able to show through the trial that you actually enhance the inactivation of the backwash water, so the disinfection of the backwash water, which is a new concept that we showed in the project. And environmental outcomes, so some of the key features is a reduced chemical consumption, high performance, low maintenance, high integrity, reliability. They're all things which seem to be virtues of the technology. So in terms of adoption, now we reflect back on it, we've got all this information, what can we do with it? So we had a fairly successful demonstration, and oops, my time is up, it's the important part. So we went on a dissemination process. So Ozwater, we gave a talk that sort of involved an ABC radio interview, which was quite fun. And we also then went to the AWA conference in Brisbane. And shortly after that, we had a workshop so as everyone could come and see and touch and feel the ceramic membrane, which had full attendance. We reached maximum capacity in terms of attendance. And that led on to a couple of other things as well. So we had discussions. We're also presenting it to our scientific outlets through Intertech in November, but there's been promotion throughout the various partners. We've got a paper coming out in AWA's Water Journal. In terms of uptake, AAD, so Stephen's going to talk about the project with AAD. So this effectively uses the ceramic membrane, so there are particular metrics there that were important in that application. And in terms of adoption, so Matt Bowl has been working with us to help guide us what we do with the outcomes in terms of getting the best value out of it from a research adoption point of view. So that's it. Thank you.